Alright, so this is the conclusion to our thrilling three-part mini-series, and now we're going to talk about lambda expressions. Remember, our goal here is to understand what these little cryptic phrases mean, like O arrow O dot order date, or O arrow O greater than 100. What do those mean? Well, I've already identified them as lambda expressions, and we've said that lambda expressions are crucial to the method syntax of LINQ. In the previous videos, we demonstrated delegates and anonymous methods to kind of plug in some code as an input parameter to a method. And at that time, I said that lambda expressions are basically shorthand for anonymous methods. It's just a quicker way, a more elegant way to define and use an anonymous method. So sure, its syntax looks a little bit wild at first, but after you pick it apart, there's no more mystery to it. Okay, so let's take a look at our example that we've been working through for the last 3 videos. Alright, so step 1, same as before. We're still defining a delegate. Step 2, we're still defining a perform operation on string array method that accepts as one of its input parameters the delegate type. And then we use that method that's passed in order to evaluate whether or not we should add a given item in the strings array to a list that will ultimately be returned back. Alright, and so step 3 is kind of same as before. We don't need to define that method that's identical to our delegate definition. Alright, but you can see that the whereas before we used this syntax of an anonymous method where it was delegate and then string, and then we gave it the actual body using code block syntax. Here we're passing in something a little different. S arrow S dot starts with A. And the way you should read this is the following. Given S as an input parameter, evaluate S, and if it starts with the letter A, if it starts with the letter A, then return true. Okay, and you're saying, well, how do you get all of that out of that? Well, just look at it. If you hover your mouse cursor over, you can see that S isn't a parameter of type string S. And then if you hover your mouse cursor over this S, you can still see it's the same value. It's still the parameter that's being passed in. So this arrow is just the separator between an input parameter and the body of the method. And it has to return a Boolean, and that's just kind of the condition of this particular type of delegate that we're working with here. All right, so if you pass in this little lambda expression, given S as an input parameter, evaluate, so given a string as an input parameter, evaluate that string to see if it starts with A. If it does, then return true, otherwise return false. When that gets passed in, it operates just like the methods that we saw previously, the ones that were predefined and named, the ones that were anonymous, and now this, again, sort of anonymous method, but a shorthand for it, a lambda expression. So if we run the application, it will work just the way that we expect it to. Okay, great. So let's take what we've learned here and apply it to our bubble sort application. So let's open up another project here, and I'm going to go bubble sort lambda expressions. Okay, so in this new project, this bubble sort lambda expression, you can see that currently I have an exact duplicate of what we did in the previous video. We're using anonymous methods to pass in a delegate that will get used by the sort method to determine the sort order for each, in this case, order, but it could be, because it's a type order, but we could use it to sort integers or anything else as long as we have a way of determining whether one item is greater or should be higher up in the list than the other. Okay. So previously, we were able to get rid of a lot of code here. We were able to get rid of our definition for some pre-named methods that do the evaluation, and here we were able to do the same and just get rid of an entire class that would be used to sort integers. All right, this time what we're going to do is shorten this anonymous method syntax. So what I'm going to do is just delete this whole thing right here, and I'm going to start over again. So O1 and O2 are the input parameters. Then I'm going to evaluate O1 dot order amount, and whether that's less than O2 dot order amount. All right, and I'm going to do the same thing to the order date. So again, parameters O1 and O2. Then we're going to check O1's order date. And notice how we get full IntelliSense here. That's pretty neat. It knows what we're talking about. How does it know? Well, hold on, I'll tell you. All right. It knows because when we defined our sort bubble class, let's go down to it. We know that we're accepting a type T, and that type T is used then in the definition of both the list and then the sort comparer. So the sort comparer has to take the same type. In other words, we have to accept the same type as the bubble sort algorithm itself. Well, where is this defined? Let's go to that definition. And here's our delegate definition. If we're going to accept type T, then we're going to accept T as the first item and T is the second item. In other words, if we're going to accept an order here, then the first item it would expect to be an order, and the second item would expect to be of type order. All right, so that's how it knows what we're attempting to do, because we've defined sort order here. All right, so let's run the application and see how it works. All right, so it still works, and it still seems to sort correctly here by order amount from least to greatest, and then from order date from earliest to later. And we just have one more thing to do then, is to replace this. What do you think it'll be? Well, if I was a betting man, I would say it would be this. And let's see if I'm right. And it seems to still work. Okay, so no big deal, right? As long as we understand the syntax, that we're passing in, these are the input parameters, and this is the body of the method, and it has to return a Boolean. As long as we're good with that, then we understand what Lambda expressions essentially are, okay? And so let's do this. Let's open up one more quick example here, because I want to show you that we really don't even need our delegate definition here. We don't even need this. Let's come back to this example in just a moment. In the meantime, let's open up an example called funky. You might be wondering why I am saying that. Well, if we take a look at this example that we've been referring to, we've had this function for string. We looked at it earlier today. We defined it as a delegate that accepts string as an input parameter, and then a Boolean is an output parameter. But what if we were to make it more general, more generic, and we were to say, go ahead, instead of a function for a string, make it a function that'll work with anything. And so, function for anything, you tell me what type you want to use, and as long as you pass in an instance of that type, I can work with you. And so this perform operation on string array, now what I can do is, it's still going to work with strings. I mean, I'm hardwiring this method to work with strings, but I can pass in a function for anything and then tell it what type I want to use. So this allows me to reuse this delegate definition for anything I want to. And you might be thinking, well, why is this important? It's not. Just follow me for a moment. So everything else will pretty much look the same here. This is the same that we saw earlier. The only thing that I really changed here is that I made this delegate definition generic, and then I pass in the specific type I want to use. So when I run this, it still works. All right, so what about that? Well, by making this function for anything so generic, we can use it all over the place for any type, as long as we only need one input parameter and as long as we accept back a Boolean. All right, so I could define this once in my project and then use it everywhere. So we could create a couple of these delegates, you know, a delegate that accepts two input parameters, and a delegate that accepts 3 input parameters, then use them anywhere in my project. And so Microsoft has already done this and has saved you the trouble of doing it yourself. They've created a delegate called func, F-U-N-C, that they use in LINQ that serves this exact purpose. So whenever you're working with IntelliSense and you see that it accepts a func with an input or a func of type int, bool, then you know that func is a built-in type that was created by Microsoft for this exact purpose. A generic function for one parameter and a generic func for 2 parameters, and then a func for 3 parameters. It's defined them up to I think 8 parameters. So every LINQ extension method utilizes at least one of those predefined func delegate declarations. So what we could say is this. Let's just comment out this work. Gone. And now that'll create an error here, right? But watch what I'm going to do. Well, actually, let me do this. Let me copy this. And then I'm going to comment it out so you can still see it if you were following this at home. And then what I'm going to do is just do this. Func. All right, and you can see the IntelliSense pop up, and you're like, whoa. You can see there's 16 generic overloads for this, but all we need to do is that. So what this is saying is we're going to use a delegate definition that accepts as an input parameter 1 string. Now, if we had one that needed 2 strings, we could do that, right? So now there would be 2 input parameters and then 1 return value. In this case, our operation only needs 1 input parameter of type string, and then it's going to return a Boolean. All right, just like our add operation, our operation will actually do, and we'll use that as an evaluator. So what's actually going to be passed into this? Well, nothing changes. Here, we're passing in a single string to satisfy this generic part of the type. And then we're going to return a Boolean, which satisfies this part of the type. So now if we were to run this application, awesome, it still works. So I could delete everything in this application that's in green, and I would have a nice little compact application that did exactly what the first version of this 2 videos ago did, and would allow me to do something like this as well. And you see how pluggable my application has become, how extensible it's become, just because I've used a little bit more elegant syntax to define that input that I want to send into my method that does the evaluation. And that is exactly how the LINQ extension methods work with Lambda expressions. So here we have, in this video, we learned about how to interpret a Lambda expression. And we noticed that it's really not that difficult. It's just an anonymous method, and an anonymous method was really just a method without a name. Okay. And we just pass in those values to other methods that might need to evaluate something based on that criteria. That's easy. And then we learned that Microsoft saved you all the trouble having to create your own delegates by using this func, F-U-N-C delegate. Furthermore, it uses that func delegate all over the place with LINQ. So when you see the IntelliSense pop up, don't worry about it. All it means is that tell me how many input parameters you need, and then tell me what the return value is. And almost every single one of the LINQ operations will accept 1 or 2 input parameters and then return a Boolean. So as long as you understand that, you're gold. And so as we work through the next examples and actually now get a chance to talk about LINQ, there's no mystery involved anymore, right? This is easy stuff once you wrap your brain around it. So if this doesn't make a whole lot of sense, don't worry. You're going to see tons of examples. You don't need to know any of this. You could just blindly accept how LINQ works with the expression, with the query syntax, with the method syntax, sorry. and just say, okay, I know I just need to pass in, and just look at an example from help and say, oh, I need to do O arrow O dot whatever, and that'll create a where clause for me. Okay. You could just accept it at that level and life will be good. But now you know that there's no mystery here and what's actually going on behind the scenes. And hopefully that'll help you decipher and make good decisions as you're working with LINQ. Okay, next video, we talk about LINQ proper. We get into the nitty-gritty of it, and it's fun and easy stuff. So we'll see you in the next video. Thank you.